Folks, today we are going to talk about really the last step to factoring and the types we haven't looked at yet. So right now we have talked about factoring out a greatest common factor. We've talked about what to do if perfect squares show up, either difference of squares and perfect square trinomials. But now we're going to talk about polynomials that look like everything else. Okay, so maybe there's a GCF, but we're still quadratic, we're still seeing a squared, or maybe we don't see perfect squares at all. Okay, up until this point, that may have been called prime, but there's other steps we can take to see if it can factor more completely. Okay, so as a refresher, okay, the first step we're always going to look for from what we did before is look for a GCF. Okay, that can be a number or a variable. In this case, it's just a number, and then what we've seen inside here hasn't looked like quadratic yet up until this point. So that's what's going to change today. This right here is quadratic, but not perfect squares, so we'll see how to actually factor something that looks like this. Then I had you look for perfect squares. There were either two terms on your perfect squares, that was our difference of squares, that factored into things with opposite signs. And then there was the perfect square trinomial from last time, where we still took the square roots, but they were both the same sign, so both plus or both minus. And sometimes it was better to write it in that squared version to help us solve equations. What we're going to look at is the formatting today when we see something like this. And we're going to focus mostly on when A isn't 1, because when A is 1, it actually is the same process, but we can kind of skip a step. So we're going to start with the harder one. And it's going to go back to what we did in Chapter 8 with our box method for foiling polynomials, okay? So to start out today, we're going to look at two binomials that we're multiplying together. And again, the goal is to start with this and end with this, but I've given it to you right now so we can kind of talk through the relationships. So what I want you to do is actually FOIL this using the box method. So set up a box to the side here. I'm going to let you pause the video and actually take care of that for me, please. All right, you should have gotten something that looks like this, and remember those middle terms are going to combine together to create that middle term of 8x. And why it's going to be important for us to look at this box is we're going to talk about working backwards today. And working backwards means we'll have these values, kind of, okay, because we'll be given these numbers. And then we come up with these ones actually just by using GCF like we've been practicing all chapters so far. This first value here is the GCF of this column. This value is the GCF of this column. And then going this direction, this is the GCF of the first row, and this is the GCF of the second row. And if we can know the four numbers that go in the box, all we have to do is take the GCF of everything, and that's our factored form. So it's really basic. The hardest part is going to be setting up this box. So we'll do it step by step with this exact problem. So your first step is going to be to rewrite the polynomial you're given. So we were given this 3x squared and the 4. And those two numbers are going to go in the diagonal of your box. Okay, so what I want you to do here is just look at that. This comes from the A value. I'm going to have you label it. And this comes from the C value when we think about ax squared plus bx plus c, similar to how we saw standard form of a line. Okay, so then this in the other diagonal comes from talking about the factors. Okay, so how we're going to approach this next is we're going to come up with the factors, and this is what's new today. Okay, we're going to talk about how this relates to everything we've been doing with the product and sum. So here's how it works. You're going to make that little diamond, and what you're going to do is you are going to take the A times the C, and this I'm going to call, I'll have you right at the top, frowny face factoring, okay, because you're going to make a frowny face from A to C, and that's what's going to go in the top of your diamond, AC. And then what's going to go on the bottom of your diamond is the B value. And your job is to fill in the rest because that's the two values that go in your diagonal. So for us, we're taking A times C, that's 12, and our middle term was 8, and that's what we're trying to multiply to get here. So multiplying to 12 and adding to be 8 is 6 and 2. And the weird part here is this is really 12x squared, and this is adding to 8x. So the way that's going to work for us is if both of these have an x attached. And when we write them in here, it actually doesn't matter which order you put them in, just like it didn't matter if you put 6 here or 2 here. Sometimes it's nice to think about the number that would factor nicely. I know a 3 is going to factor nicely with a 6, but I could put that 6 here or that 6 here and it wouldn't matter. Okay? So let's say we put the 6x here and the 2x here. And then all we have to do to factor this is find the GCF each way. Okay, it says find the GCF of each row and column. So we're going to talk about the rows first. If I go across here, the GCF of that is 3, and the x comes out. Here, only a 2 comes out. And what's going to be important for us, especially on these second ones, is that we think about signs. This 2 was positive, so it's really important that whatever our first term is, that's what we're factoring out, whether it's positive or negative. Okay, so we're going down here and we're doing the same thing. There's no number that goes into both 3 and 2, but there is an x in both, so we can pull that out. And it's just positive because this first term was positive. And then this one, we can take a 2 out. And again, it's positive because that first term was positive. And then our final step is just take those values and write it in factored form in whatever order you want, 3x plus 2 and x plus 2. And what you want to kind of check here, because we're comparing this to the original box from above, what you really want to do is make sure it matches your polynomial. We're saying this is the factored form of 3x squared plus 8x plus 4. So we want to make sure if we do like a quick FOIL of the first times the first, it matches up, and the last times the last, it matches up. This middle term comes from the outsides and the insides put together. So plus 6 plus 2 gives us plus 8, and that's it. Okay, so what we're going to do is just practice all of these steps. So I've given you a quick rundown of what we have been talking about each time. Is we're going to look for a GCF first, because that step from last time still applies. Okay, and then from last time, we'll look for perfect squares if there are ones. That's our difference of squares or our perfect square trinomial. For today, we're just focusing on this pattern, so we're not going to see that as much. And then we're going to follow this process we just talked about, and we'll go through those steps as we see them. Okay, so first step, we're looking for a GCF. Okay, there's nothing in common with those 3. So we're going to make a box with the a and the c value. Okay. So in our box, you're going to take this whole first term, 2x squared, and this whole last term, 6, and you're putting them in your box. We're doing that first because that is the top number of our diagonal, okay, in our diamond. We're going to multiply those 2 together to get 12x squared. Then the number we haven't used yet is what goes on the bottom, this 13x. So we're looking at the factors of 12 that add to be 13. Okay, don't worry about the x's for right now. Factors of 12 that add to be 13. Okay, the only ones that work are 12 and 1. And then you just add on those x's to finish up. Now again, you get to put these in whatever order you want on here. So I'm going to put the 12x here and the 1x here this time. And we're going to factor each direction looking for just a GCF. Okay, so here, straight down, the only thing I see is x, and it's positive because that's what this first term is. Here, we've got a 6 in common, and it's positive. Now we're going this way. Okay, so 2x can come out, positive because the first term is. Here, positive, and there's nothing in common. Now before, we didn't have to write a 1 if anything was missing. It's going to be really important on this one, and that's kind of why I wrote them this way versus the other way, is so we could see this happen. Okay, when we look at this, you have to write something because we're factoring this in to 2 binomials. something, 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 something. So we have to make sure we have terms. So if there's nothing in common, you write a 1. And then you just group them, and that's what goes in your parentheses. Again, whatever order you want. So 2x plus 1, x plus 6, and we're going to check that it works. Okay, we check that it works by taking first times first and making sure it matches this. 2x squared, it does. Last times last should match this. And outsides and insides together add to be the middle term. So plus 12 plus 1 gets us 13. That works out. Okay? Same thing on the next one. We're going to look for a GCF first. First term, second term, third term, nothing in common. So we are going to make our box because there are no perfect squares. And this box method also works with perfect square trinomials and difference of squares, by the way. But sometimes our perfect squares are so big that we don't want to take this a times the c, because I could have 36 times 49, and that's not something that we can easily break down. Okay, so that's why we did those two first. Okay, so our a is going in 3m squared, and then a negative 5 is going in. That's our diagonal. Okay, we do that first because the a times the c is what goes on top. Negative 15m squared. And then this number goes on the bottom. From here, we're looking at the factors of negative 15 that add to be 2. Okay, so when we have a negative, we know one of them is going to be positive and one of them is going to be negative. And then I'm trying to get them so they're 2 apart, essentially. Okay, so that would be 5 and 3, but I need it to be a positive 2. So that means I need the 5 to be the positive one. 5 minus 3 is 2. We're going to put the m's on each and then plot them in. So because this says 3 and 5 already in here, I'm going to put the 3 with this 3 with the negative and this 5 with this 5. And we're going to factor all the way across. Try to do better than me. I had a little chart here, so I didn't get far enough over. But try to keep your diamond far enough apart so you have room for these GCFs. And I'm going to go ahead and erase mine since we're done with it. Looking at the rows, okay, I've got a 3 and an m that can come out. On this one, I've got a 5 that can come out. And notice these are both positive because the first term is positive. It doesn't matter what's happening on the other side. It just matters about what shows up in front. Okay, so then going this direction here, nothing's in common with 3 and 5, but I can pull out an m, positive because the first term is. And here, I can only pull out a negative 1 because there's nothing in common, kind of like last time. So then when I regroup it, this says 3m plus 5 and m minus 1. Let's check it because this is the first time we've seen a negative pop up. Okay, so 3m times m should be my first term. That's good. Last term times last term should equal this negative 5. 5 times a negative 1, that's good. And then outside and inside together combine to be the middle term. So minus 3 plus 5 gets us to a positive 2. It checks. Okay. We're going to just keep practicing because there's a lot of steps here, but once we get the steps down, it's going to go really quick. And you may end up liking this one better than even the perfect square ones. Okay, so first step is look for GCF. Okay, nothing there. Then we're going to make the box. I'm going to actually have you pause the video for me right now. I want you to fill out this box and set up your diamond, and we'll do the rest together. Okay, so try that for me now. Okay, hopefully you remember this is your A and your C first and last term, assuming it's in order. Okay, and then we're going to use that to make the diamond. I'll put it on this side this time so I don't run into my factors. So this would be 14r squared. And then the number I haven't used yet, the negative 15r, is what goes here. So I'm looking at the factors of 14 that add to a negative 15. Now remember, the only way to get a positive is both positive or both negative. Okay, so they have to be both negative, and it's 1 in itself. Tack on the r. So then in here, I just plop those numbers, whatever order I want them in. It does not matter. and then we're going to find the GCF all the way around. Okay, so I'm going to do the rows first. Here, an R can come out. And I'm putting positive, even though there's a negative in this row, because it only matters what's first. Okay, on this one, I've got the negative first, so this one I do want to factor out a negative. And this one, a 2 can go in. Going down, a 7 and an R shows up. Okay, positive because the first term is. And this one, negative because the first term is. And nothing goes into that, so we just write a 1. Group them and rewrite them. R minus 2, 7R minus 1. We're going to check always that these work out. R times 7R gets me to 7R squared. That's good. Negative 2 times negative 1 gets me to positive 2. That is good. And then I've got a negative 1R and a negative 14R. That's my negative 15R. Perfect. Okay. Next one. I'm going to let you try the whole thing this time. Okay, the whole thing. And we'll check it together. Pause the video and try that for me. No GCF, so in my box you should have the 2m squared and the 3. We're multiplying those together for the diamond. That's 6m squared. And we're trying to get to negative 9m. Okay? If we think about all the factors, 6, 1, 2, 3, there is no way to get to a negative 9m. It's not possible. Okay? I'm wondering how long it took you to realize that you were stuck here, because the only combinations here, we know this is negative, so they both have to be negative. The only combinations that are possible are these ones, so the only options I could have for my middle term are negative 7 and negative 5. That doesn't work. Way back at the beginning, it said if the polynomial cannot be factored using integers, meaning nice numbers, then you're going to write prime. This is an example of something that cannot be factored. It is prime. Okay, and you will see that every now and again. Don't immediately get stuck and think that it's prime. I want you to, when you're stuck, list out all the factors that are possible so that you are sure that there are none that go in evenly. All right, now we're going to talk equations. Same process, but then we're going to solve. Last step, we're going to solve using the zero product property. So that's where we set each of those pieces equal to 0. Okay, same process before. Looking for a GCF, there isn't one. Okay, so we're setting up a box. In our box, we're putting this 2x squared and this negative 3. And then we're building our diamond to help us out. Negative 6x squared. And then the number we haven't used yet down here. If we are multiplying to a negative, we know one has to be negative and one has to be positive. So we are looking for the factors of negative 6 that add to be negative 5. Okay, they have to be 5 apart from each other for that to work. Okay, so I have to use 6 and 1. It will not work to use 3 and 2. Even though those add to be 5, when one's positive and one's negative, that doesn't work. Okay, so I need it to be a negative 5, so it's got to be negative 6 and positive 1. We'll throw those in our box with x's attached. And then we just go GCF all the way around. So first row, looks like we've got a 2 and an x. It's positive because the first term is. Here, there's nothing in common, but the first term is positive, so we use a plus 1. Okay, going down, nothing in common but x. Again, it's positive because my first term is. Down here, we've got a negative 3 because that first term is negative. We have to factor it out. That's the only time we put a negative outside, is if the first thing you see is negative. Group them and check. So we've got 2x plus 1 and x minus 3. And we're checking it with this equation up here. So we want to make sure it matches with the equal 0 as well. That's going to be really important here. 2x times x gets us the first term. That's all good. Last term times last term is negative 3. That's good. And then negative 6 and positive 1 gets us negative 5. It all checks out. So this is the extra step that we're talking about. We're going to put this equal 0 so that we can solve using the zero product property. The only way to multiply, which is what's happening here, to get 0, is if one or both of these pieces equal 0. So that's how we're setting it up. First piece equals 0, second piece equals 0, and solve. Subtract 1, divide by 2. First answer goes in. Add the 3 over. Second answer goes in. And you're done. Okay, I'm going to show you on this one, but we're not going to spend time to do it on every single one. I do recommend to do this when you come to a quiz or a test because you've got a bit of extra time. Okay, you are always okay to check these, and you should, in the original equation here. So how this looks is 2 parentheses instead of x. We're going to plug in the number we got. 1/2, close it. Then we're squaring it. And then minus 5, close it, or open my parentheses, negative 1/2 again. Close it. And then minus 3. All of that should simplify to regular 0. It does. We can do the same thing now with the number 3. And I'm going to go up here and just change those numbers. Just to a regular 3. And it should come up to 0 as well. And it does. Okay, so final answer is that, but I will grade your factored form as well. So those are the 2 things I'm really looking for here. All right, let's check out this next one. All right, we got equal to 0. We're going to look for a GCF still. Okay, there isn't one. Now, I do want to kind of get you prepared for what's coming next couple times as we're practicing with these all mixed together. You do want to still look out for perfect squares. This 9n squared is a perfect square, but this 2 is not, which means the box method is still the best option for us. Okay, so we're going to go ahead and set up that box. A 9n squared and the 2. And then we're multiplying those together to get this top 18n squared. Number we haven't used yet goes in the bottom. So we're looking at the factors of 18 that add to be 9. Okay, so that's 6 and 3. And then we're plopping them in, whatever order you want. And then we're going to find the GCF all the way around. All right, so first row here, 3 and n goes in. Second row, it looks like just a 2. Let's talk signs. Both of these first terms were positive, so positive for both. Going this other direction, going down, looks like a 3 and an n can go in. Okay, over here, nothing goes in, so that's a 1. Again, these first terms we see are both positive. Group them, and let's rewrite. 3n plus 2. 3n plus 1, and we will always check it with this equation before we move on. Really important that it works out for us. 3n times 3n is 9n squared. We're golden. 2 times 1 is 2. That works out. And then outside and inside, we've got plus 3n plus 6n. Those are those same numbers. It does add up to 9. Works out. So then this last step is each piece equal to 0. To solve. So 2 steps on both of these. Move that constant first. And then divide by the coefficient. First answer looks like negative 2/3. Second answer looks like negative 1/3. Again, same thing I talked to you about last time. Okay, you can check those answers in your equation. Okay, you should on a quiz or a test. And then I'm looking for 2 pieces, this and your factored form, making it equal to 0. Okay. These ones are a little bit different because they're not equal to 0, but it's the same process. Okay, last time we said sometimes if it's not equal to 0, that's a good thing because perfect squares are showing up. This 4a squared is a perfect square, but this 5 is not. So now we have another option, okay? We can subtract this over to get it equal to 0. And that's really the ugliest it's going to look. So 4a squared minus 18a negative 10 equals 0. And sometimes when we do that, we end up seeing a GCF, because that's step 2. So in this case, we're looking for a GCF, and there actually is one. It's really important that you find that first. Otherwise, this isn't going to work out as nicely. So here, we're going to look for a GCF, and the number 2 goes into everything. We're left with 2a squared minus 9a minus 5 equals 0. Why we're doing this is because now our numbers inside are much smaller, which means the values in our box are going to be smaller and easier to work with. If we forget a GCF and that GCF is like 10, the factors that go into our diamond are too big for us to work with. Okay, so it saves us a lot of time and it's required. So 2a squared, we're using just this inside stuff, and the negative 5 go in. And then in our diamond, we're going to have the negative 10a squared. Again, it's called brownie face because we're multiplying those two together in our parentheses in this case. Middle term is what goes down below. And we're looking for the factors of negative 10 that add to be negative 9. And we've got a negative 10 and a positive 1. A's on both. And whatever order you want when you plop it in does not matter. And then we're going to GCF all the way around. So first row, we've got just an A, positive. This one, we've got a negative 5. Going this direction, looks like 2A. Okay, the negative is on the second one, so it does not apply. There's a positive first. Same thing with this one, has to be positive because the first term is. So plus just a 1, since there was nothing else in common. Group and rewrite. A minus 5 to a plus 1. And we're writing it just like the original. So here's the thing, that 2 is coming down and the equals 0 is coming down. Really important. Because we're trying to say that this is the same as that one. So let's just check this inside version because we know our GCF is right. So a times 2a squared, negative 5 times positive 1, negative 5. Outside a, inside negative 10, gives us negative 9. We're good. So 3 pieces on this one, each equal to 0. This one doesn't work, okay, because 2 is not equal to 0. Then we're going to solve the other ones. Not sure if you've noticed a pattern by now, but we're always going to just take the opposite of what we see here, so that's 5. And then if there's a value in front, we're still taking the opposite of this, because we still see that minus 1 show up instead of a plus 1. But then there's the extra step of you just throw the front number underneath. These should never reduce in your answers, because if they can, it means you left out the GCF. So 2 parts, factored form, and your answers. Okay. Do this one, 8m squared minus 44m. This time, this was just on the wrong side, but it can't go with anything. So we're just adding it over. Okay. What I want you to do is pause the video while you look for a GCF, because there is one here, and set up your box. We'll talk about factoring and solving together. Okay. All right, hopefully you found your GCF was 4, and that looks like 2m squared minus 11m plus 12 equals 0. So then in your box, we would put the 2m squared and the 12. And then we would multiply those together to get 24m squared. And we're looking for a negative 11. That is possible. You can have an 8 and a 3 as long as they are both negative. And we tack on an m. So I'm going to put a negative 3 here, and I'm going to put a negative 8 here. Again, order of these does not matter if you have it flipped around, all that's going to mean is in your final form, maybe they're in a different order. It doesn't change your answer. Okay, and then factoring through, hopefully you got a positive 2m here, a negative 3 here, and then going this direction, regular m, and then a negative 4. So when I group these, I've got m minus 4, or you could have written the 2m minus 3 first. But we're going to check that it works by putting the 4 down here, and putting the equal 0 down here, and making sure that this is exactly equal to that step. So m times 2m, that works out. Negative 4 times negative 3, that works out. And then minus 3 minus 8 gives you minus 11. We are good to go. 3 pieces equal to 0. Now let's solve. 4 equals 0, doesn't work. M minus 4 equals 0. 2m minus 3 equals 0. So here's what I was talking about. This is just going to add over, change to positive 4. This is going to add over, be positive 3, but then I have to divide by 2. That number goes below. And that may save you a little bit of time. All right. We talked about this, but what I want you to do real quick is draw the flow chart, meaning we've talked every single step about the order of things that you need to be doing things in. Okay, so step 1 has to be what? For everyone, no matter what. Then we're going to split it into whether there are 2 terms or 3 terms. Okay, either way, the next step is look for what? Okay, and then after that, we're doing what we did today. Okay, so first step, hopefully, we all know that is GCF. Then, what you're going to look for next is always perfect squares. But perfect squares could have 2 terms if it's a difference of squares, or it could have 3 terms if it's a perfect square trinomial. Okay, so an example of a difference of squares would be like x squared minus 4. Okay, there's only 2 pieces, but both of them are perfect squares. Difference means minus in the middle. That factors into positive version of the perfect square, or square root, excuse me, and a negative version in whatever order you want. Perfect square trinomial, okay, I'm going to start actually backwards from this. These signs have to match up. Okay, so I would have like x plus 2 and x plus 2. So when I look at this, it's x squared plus 4x, remember double this, and then plus 4. There are 3 terms. Okay, but 3 terms doesn't have to be a perfect square trinomial. Okay, if it's not, we're going to use the box method of what we talked about today. Okay, that's kind of the thought process you need to think through. And then if it's an equation, that's when you're going to solve. And I have a nice printed version of this that I can give you. I just want to give you the heads up. This is not going to be able to be something you can use on the test. Okay, you got to know it. Last thing on here is review, just a couple review problems. What I want you to do is pause the video and try them for me, and I'll flash up the answers here in just a minute. Alright, this one looked like the box method, and we're going to talk next time about this special pattern when it's regular x squared rather than some number in front. But what we learned today, it looks like this, and we've got a -1 and a -9, because there's really not much that can be factored out when we go that route. And then this one was a difference of squares. If you would have done the box method, the diagonals would have had to add to 0 because there's nothing in the middle, meaning these would have to be opposite signs that end up canceling out. Okay, it's possible, but it would have taken you forever to figure out the factors of 81 times -4 to finish it out. So don't forget to look for perfect squares and then use your patterns to write your final answer.